So let's start. Uh, so we are about to solve the 91-92 page exercise, I think. A group G is indecomposable if and only if huh? I don't understand this problem. What was the definition of G being indecomposable? Anyone? What was the definition of indecomposable? Who is this Abhishek, by the way? One one of them is Abhishek Ghosh. There is another Abhishek. Who is it? What was indecomposable, by the way? The definition of indecomposable, Rahul? I mean, they mean a number of things. But what does Hungerford exactly mean by saying indecomposable? GHI. Or maybe decomposable. Maybe I should look for the word decomposable. Decomposable. No, I'm not seeing the. Where is. What does it mean of being decomposable?
হ্যালো, তোমার কথা শোনা যাচ্ছে না।
Oh, I have been. I have been talking all along. I just forgot to unmute myself. Okay, what is the definition of indecomposable, by the way? What? Where is it given? The definition of indecomposable? Forget it. Again, it is given to be indecomposable again, so we need that. What the hell is that? Just a minute. Are we doing the right exercise? No. Oh. At least some of you should tell me that this is the previous exercise. Okay. So G be a group. A is any normal abelian subgroup of G. G mod A operates on A by conjugation. Obtain a homomorphism. Yes. So what is that? A is abelian, huh? So G mod A is acting on A, right? By conjugation. That is, suppose GH is here and A is here. I'm sorry, not GH. GA is here. This sends A to GA G inverse. There is the only operation. Obtain the homomorphism. Is it a well-defined homomorphism? I mean, if GA is equal to G prime A, which means G prime G inverse G prime, G inverse G prime belongs to A, then A is abelian. So is GA G inverse equals to G prime A G prime inverse? Is it so? So if we take G prime G inverse G prime A, since A is abelian, we get A G inverse G prime, right? Which is, yeah, it is true. It's true. Just so we get GA G inverse is G prime A G prime inverse. Yeah, it is true. So the action is well defined. Now please, anyone? Ma? So what is the map from G to what A? So what we were doing is that if this is an action, then we saw that there is a map from G to Otis, right? What was that? We were sending G to tau G, where tau G is a map from S to S, where S was going to G comma S, right? This was the map. This was GS, G inverse, maybe GS, depending on the action. So GA will go to tau GA, right? Where tau GA is a map from A to A given by tau GA of small a is GA G inverse, right? So that's what they have asked for. And obtain a homomorphism and so on. So this is a homomorphism. We have checked it in the last class. Okay. So what is 2? HK and subgroups of G.
দাদা
Yeah.
বলছি ফার্স্ট অঙ্কটা মানে আমি ওই একটু অন্যভাবে করেছি, মানে একটু
Of
দেখবে?
course. Go ahead. Yeah.
হ্যাঁ, আমি পাঠাবো হোয়াটসঅ্যাপে।
Tell here na.
দাদা বলছিলাম যে আমি ওই মানে জি এ যেটা আছে সেটাকে মানে জি এ জি ইনভার্স না করে মানে আমি কোসেটটা নিয়ে নিয়েছিলাম, তো সেটা কি হবে?
How? tell me the map from G cross
মানে
A comma A to A. Okay. So what you are
হ্যাঁ,
taking GA comma A, you are sending it to
জি এ মানে জি ক্যাপিটাল এ
hmm,
ডট এ ডট জি এর হোল ইনভার্স।
which is this GA G inverse A, na? You are doing this, na?
হ্যাঁ,
Yeah, but the problem is that it is not defined, na? I mean, G capital A and these things, I mean, you can't multiply these things, you understand? GA is an element of A,
আচ্ছা,
small a is an element of capital A, G inverse A is again an element of G mod A. So, this product is not defined.
মানে কম্পোজিশনটা মানে ঠিকঠাক হচ্ছে না, তাই তো?
Exactly. I have done the exact same thing. Just you have to take G, otherwise, you can't do the product.
ঠিক আছে দাদা, বুঝতে পেরেছি।
Okay. Hmm. Okay. Okay. I mean, okay. Who told Doipayan about my classes? I mean, is it Ritik or is it Shayan? Hello.
আমি তো বলিনি দাদা।
Yeah, Ritik. I mean, he's saying that he got my number from Ritik. Yeah, I mean, WhatsApp status of Ritik. Ritik, do you know Doipayan? Is Ritik here? Yeah. I have not been able to get in touch with Doipayan for a while now. Ritik, can you hear me? So let's do two. So H normal in K, show that K is a subgroup of NGH. Okay. So how do we show it?
দাদা এখানে কি এটা সাবগ্রুপ অফ এনজিএইচ বলছেন?
Yeah, subgroup.
হুম,
Which means NGH is the largest subgroup of G in which H is normal. Okay. But how do we prove it? Anyone?
দাদা আমি মানে কে এর থেকে যে কোনো একটা এলিমেন্ট নিয়ে দেখিয়েছি যে সেটা মানে এনজিএইচ এ কন্টেন্ট করছে, তার মানে তো পুরো কেটা এনজিএইচ এ কন্টেন্ট করছে,
You are saying this is by
তাহলে তো
definition,
হবে।
na? You are saying this is by
হ্যাঁ,
definition. For any K belongs to K, KH, K inverse is inside H. This implies K belongs to NGH. Just by definition, na?
হ্যাঁ দাদা।
But I am thinking, is it way too easy? Yeah, but I mean they have defined it that way. These are I called warm up exercises of hunger food. If a group G contains an element A having exactly two conjugates, then G is a proper normal subgroup. I am just asking one thing. Is it Shorvani I am talking to?
না দাদা, আমি আরোহিণী।
Oh, I keep messing that up. I think you can switch your names. Okay.
না দাদা,
See, so A having exactly two conjugates. Okay. So A is E inverse, right? So A is its own conjugate. So one is A. Another is maybe G inverse for some G. Okay. Okay. So G has only two conjugates, no?
হ্যাঁ দাদা।
So now what we do? Take, let's denote it by B. Let's denote it by B. So take G belongs to, this is an arbitrary, take any G belongs to capital G. Now see, what is G inverse? What is this?
কনজুগেট অফ এ।
Yes. So if it is A, what is G inverse? So case 1, G
ওই তো
inverse
এর জায়গায় বি ইনভার্স বসিয়ে দেব।
how? A has two conjugates, one is A itself and one is B inverse. How can you substitute A by B inverse?
ও
ZG implies ZG is non-trivial. Okay. Implies ZG is the normal subgroup of G which is non-trivial. Okay. And case 2, G inverse is equal to B inverse. But what does that mean? What does that mean? You multiply this by G, so we get A equals to GB A B inverse G inverse, which is GB A GB inverse, na?
হ্যাঁ দাদা।
So this implies GB A GB is GB A, right? So GB commutes with A. GB commutes with A. How to proceed after that?
না, এটা ওই লাইনটা মানে A ইকুয়ালস G ইনভার্স B হবে।
Oh. No, okay. I mean, let's try with group action. Shouldn't have went in an elementary way. So so what is GA, by the way? What is GA? G is acting on G by conjugation. Okay. What is GA?
স্টেবিলাইজার অফ A।
Right. So all those G belongs to capital G such that GA G inverse is A, right? And what is theta A? GA G inverse such that G belongs to capital G, right? Right, the orbit of G.
হ্যাঁ
And we know that theta A is equal to G mod GA, isn't it? Right? Given theta A is 2, isn't it? We have been given that theta A is 2. A has only 2 conjugates. It implies G quotient GA has index 2. This implies GA is normal in G, isn't it? Because any subgroup of index 2 is normal in G, no?
হ্যাঁ দাদা।
Okay. So, 4. H be a subgroup of G. The centralizer of H is the set of I was about to cross it. Oof. So centralizer of H is the set CGH such that all those G which commute with every H in H, right? So you have to show that this is a subgroup of NGH, isn't it? Okay. This is obvious, no? Isn't it?
হ্যাঁ দাদা।
Is it obvious? By definition. But can we claim something more? Can we claim no, actually we can't claim much here. Yeah, we can't claim much here. This is good. The point of exercise 4 is to introduce exercise 5. Okay, see, I will give you a few minutes to try this. At least try this. Hello. So what did you do?
We can define at first বাংলায় বলছি সিজি তো সিজি ইজ তো একটা নর্মাল সাবগ্রুপ অফ এনজিএইচ
CGH is a normal subgroup of NGH. Are you sure?
ইয়েস এবার আমি
So he is saying that observation 1. What? Observation 1 is that, oh, what the hell I am writing? CGH is normally NG. Then
এনজিএইচ
See, I'm telling you one thing. Whenever you see this sort of things, like either the factor this is isomorphic to a subgroup of this, so basically what you will have to do, you will have to do this quotient. You will have to give an injective map from this to this, right? Right. Which means you will have to give a map from this to this, whose kernel is CGH, right? I'm back calculating, right? So that's what you will have to do now. So why not act this on this? Why not do this? And the very obvious map is this. Isn't it? So now by this action we know that there exists theta from NGH to odd H, where G goes to tau G, where tau G is a map from H to H, sending small h to G inverse, right? If we show enough to show card theta is CGH, right? Once we can show this, we are done, na? Okay, so let's see what card theta is. So card theta is G belongs to NGH such that G H G inverse equals to H, right? I mean, I should be writing like this. Thus that theta of G is equal to tau of G is identity, right? That is G belongs to NGH such that so tau G, I mean, I should be writing like this. Tau G of H is H for all H belongs to H, right? That is G belongs to NGH to NGH such that GH G inverse is H for all H belongs to H, right? What was it? This is CGH, na? Right? So we are done. Thus NGH quotient CGH or H. All okay? Okay.
তাহলে এখানে থিটাটা ওয়েল ডিফাইন্ড আর হোমোমরফিজম প্রমাণ করতে হবে না?
See, whenever we are acting a group on a set S, if you recall, okay, who asked me this? Is this Shorvani now?
না, আরোহী।
ওমা এটা বন্ধ করো। Okay, so Arohini, your voice has changed in between. Last time you spoke in a different voice, I'm sure. So for any group G cross S to S, G comma S belongs to S, na? This is any action. Okay, any action induces what? Theta from G to odd S, where G goes to tau G, right? And tau G is defined from S to S by S going to G comma S, right? G comma S is in S, na? I mean, not is in S. I mean, I should write like this. This action, let's write it by psi. This I should write psi of GS. Okay. Psi of GS is in S, na? I mean, this psi of GS can be GS, it can be GS, G inverse, whatever it is. So this is my automorphism, right? This is tau G. Now you are asking whether theta is a group homomorphism well defined or something like that. So if you see that suppose G equals to G prime, then psi of Gs is equal to psi of G prime S for all S. Since psi is well defined, as psi is well defined, thus you get tau G of S is equal to tau G prime of S for all S. Okay. Thus tau G is equal to tau G prime. Okay. Now for homomorphisms part, suppose theta G plus G prime is here. So you get what? Tau G plus G prime, right? So act this on tau G of G prime on S. What will it be? Psi G plus G prime on S, right? Oh, I shouldn't be writing like plus because plus is the group operation, na? So I shouldn't be writing like plus. I should write like this. G compose G prime, na? G compose G prime, comma S. Now what is this? We know that this is this, right? Right. So what is that? Tau G of G prime S. But what is it? What is this? Wait a minute. I have written tau G of this. This is not, I shouldn't be writing like this because tau G of, I should be writing like this. No, wait a minute. What was that? Tau G of S is, tau G of S is psi G of S, right? Okay. So this is no. Oh, just because of that. Right now. This is the correct thing, na? Because the group action is associative, na? So what is it? This is tau G of psi G prime S, right? What is psi G prime S? That is tau G compose tau G prime of S, isn't it? That is, you get tau G compose G prime is tau G compose tau G. Okay. Is it okay now? Okay, I understand. Arojini, you are stuck at this step, na?
হ্যাঁ দাদা
What was the definition of group action? A group action means psi E of S is S, na?
হ্যাঁ
And what was it? Psi G of G prime S. What was it? You have seen this way. G prime dot S is G prime dot this. This you have seen, na? But what is this dot? This dot is replaced by psi, na?
ও আচ্ছা আচ্ছা হ্যাঁ বুঝতে
Okay,
পেরেছি
right now it is okay now, na? So this is this.
হ্যাঁ দাদা বুঝতে পেরেছি
Okay. So theta induces G to what S, a group homomorphism for any set S for any group G. So you don't need to check separately for each group action. Okay. Okay, let's go to this. What about this 6? It's a big problem. গেল কোথায়? Suppose G acting on a set S containing at least 2 elements. Assume that G is transitive. You know the meaning of a transitive action?
না দাদা।
Why not? Transitive action means which has only one orbit. Okay. Transitive, an action is transitive if for any x y belongs to S, there exists G belongs to capital G such that G dot x, I mean group action, this goes to Y. Okay. Okay. That
হ্যাঁ
is
দাদা।
uh, S is equal to theta x for any x belongs to X. Understood? So basically there is only one orbit. Where was it? Okay. So that there exists G. Yeah, this is the definition of a transitive action. They have given it. For x belongs to S, the orbit x bar of x is S. So that is by definition, na. By definition of a group action, by transitive group action, we can see that S has to be theta x, because for any S belongs to, because what does this mean? This means this Y is in theta x, na. This Y was arbitrarily chosen. So theta x is S. That is obvious. What about 2? All stabilizers Gx are conjugates. Okay, let's see. So what is a stabilizer? So Gx is all those G belongs to G such that Gx is X, right? I mean G dot X, I should be writing it. The way I'm writing Gx is like I'm multiplying X by G. This dot is the group action, huh? Okay, so what was that? So they are saying that all the stabilizers Gx are conjugates, and take another Y. G belongs to capital G such that Gy equals to Y.
আগের প্রুফটা একটু বলবে এটা কিভাবে হচ্ছে?
Who is this? Ognidipto?
না দাদা, প্রীতম।
First think. Okay, I will give you 1 minute. Carefully read the definition. Just read the definition carefully. Okay, but
হ্যালো,
what
হ্যাঁ
is
হ্যাঁ
that,
ঠিক
what
আছে,
is okay now, na?
হ্যাঁ হ্যাঁ, ঠিক আছে।
Yeah, that's what I was telling. Yeah, so let's take, so we will have to show that these are conjugates of one another, na? So since the action is transitive, there exists g naught such that g naught x is y, right? Right? So let's take h belongs to gx. Okay, so what about this? What about g naught h inverse h of x? What is it? What is it? H inverse g naught hx, which is x, na? So h inverse g naught hx is x, since h is from gx. What is h inverse g naught y? What is that? What is g naught x? That is y. It is h inverse y. No, I'm not doing it correctly.
আমি এটা করেছি।
বল।
সাপোজ ওই জি, সাপোজ জি ডট এক্স ইজ ইকালস টু এক্স, সেটা হচ্ছে জি এক্স, আর জি ওয়াইটা হচ্ছে এরকম ভাবে জি ড্যাশ ওয়াই ইজ ইকালস টু ওয়াই। এবার ওইরকম জি জি জিরো এক্স ইজ ইকালস টু ওয়াই। তো আমি কি করছি, ওই ওয়াইটাকে জি জিরো জি জিরো এক্স দিয়ে রিপ্লেস করছি, করে একটা জি 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 জিরো ইনভার্স বোথ ইকুয়েশনের বোথ সাইডে আমি অ্যাক্ট করিয়ে দিচ্ছি। তো আমি পাচ্ছি ওই
Yeah,
জি
he is saying
জিরো
this.
ইনভার্স জি ড্যাশ জি জিরো এক্স ইজ ইকুয়ালস টু এক্স, তার মানে ওই তার চলে এলো।
He is saying this.
হ্যাঁ,
সেটাই
না
বলছিস
তো
তো?
না তো এরকম।
হ্যাঁ এটাই বলছিস। So hy is from gy, na? So what do we get? We get g naught inverse h g naught x. Now g naught x is y, we put y. H is from gy, so hy is y, right? And g naught inverse h, y, what is that? See here, that has to be x, na? So what does it mean? It means g naught inverse h g naught belongs to gx, right? Since h was arbitrarily chosen, we get that, right? That's what we get, na?
হ্যাঁ দাদা।
Abhishek was saying the same thing, I think. He just had made some calculations in a different way. So now if you take h belongs to gx, and if you just do g naught g naught h g naught inverse y, what is g naught inverse y? That is x. So g naught h x, now hx is x because h is in gx, that is g naught x, it is y. So thus you get g naught gx g naught inverse is a subset of gy. Understood?
হ্যাঁ দাদা।
So gy and g naught are conjugates, na? So by this you get gy is contained in g naught gx g naught inverse, and here you get this, thus gy is g naught gx g naught inverse. Okay, so they are conjugates, right Abhishek?
হ্যাঁ
Okay, so now see, if G has the property that G belongs to capital G, Gx is X for all X belongs to S. If G has the property G belongs to capital G, Gx equals to X for all X in S. What? Okay, is E. Okay, which is the case if
এই ইটা কি আইডেন্টিটি এখানে?
yeah identity of S, identity of G, which is the case when Sn, and if n is normal in G and n subgroup G for if G has the property that elements of G which fixes all S, all X, is only the identity element. Okay, okay, I get it. Okay, which is the case if G, yeah, of course. And if n normal in G and n is a subset of Gx, a subgroup of Gx for some X, I am confused between what is given and what we have to prove. Rahul, are you there? If G
আচ্ছা
has
আমি একটা জিনিস বুঝতে পারছি না, এই জিএক্স টা তো বলেই দিচ্ছে আগে যে ই হবে শুধু।
no, you don't understand. See, so let's copy the part C only. That what they are saying. So we know that G is acting on S, that induces a map from G to what S, right? Which sends G to tau G, where tau G from S to S is defined by tau G of S is G dot S, right? Right. Now this is theta. What is kernel theta? Kernel theta is all those G belongs to G such that tau G is identity of S, right? That is the kernel, which means all those G belongs to G such that G dot S is S for all S belongs to S, right? Abhishek? Given that they have given that car theta is E, understood? Now see the statement, this part. They have given car theta is E, nothing else. Don't think that G is E, which is the case. So what do we get? We immediately get G is contained in OTS, right? A subgroup. Theta is injective. And if n is normal in G, and they have said that n is normal in G, given further, n is normal in G and n is a subgroup of Gx for some stabilizer. Then we will have to show that n is E. Understood? So if n is a normal subgroup contained in a stabilizer, containing some stabilizer of X, then we will have to show that n is E. Understood? We will have to show n equals to E. So we have been given these things. So given is, I am writing this so many times so that we can get rid of the confusion, that car theta is E, that is G is contained in A or S. Then we have given in n is a normal subgroup of G such that n is a subgroup of Gx. We have to show for such an n is identity. How do you show it? How do we show it? How do we show that n is identity? So let's take G belongs to G and n belongs to n. Now G and G inverse belongs to n since n is normal in G. So G and G inverse of X is X, as n is contained in this. So n G inverse X is G inverse X, right? N G inverse X is G inverse X for all n belongs to. Now the action is transitive, na? The action is given to be transitive, right? Take y belongs to S. There exists G belongs to capital G such that G dot y is X implies y is G inverse X implies n G inverse X n dot y is n G inverse X is G inverse X equals to y, right? So this is true for all y belongs to S, na? Right? Thus n belongs to what? Cot theta implies n is identity. Understood? I am giving you a minute. Just go through the proof. I am giving you 1 minute. Just go through the proof. Is it okay now? Then I can proceed. Okay. Aravini, okay? Hello, am I audible or not? Hello?
হ্যাঁ দাদা শোনা যাচ্ছে।
Okay, then I can proceed.
হ্যাঁ বুঝতে পেরেছি।
Okay, so 6D. For x belongs to S, mod S is G mod D, hence mod S divides 6. For x belongs to S, mod S is... Oh, this is obvious, na? This is one line. Mod S is mod theta x, which is mod gx, na? Because the action is transitive, so S is theta x just. This is one line. Implies mod g. Okay. So what is the next thing? G be a group. Let in G be the set of all automorphism groups of G. Show that in G is a normal subgroup of all G. Do you remember what the inner automorphisms were? Let G belongs to capital G, then tau G defined from H to H by H going to G H G inverse. Tau G is called an inner automorphism. Okay.
আগের প্রুফটা বুঝতে পারলাম না।
আগের প্রুফটা why?
ডিটা
S is
ওখানে
theta
যে
x না, because
ওটা বুঝতে পেরেছি।
then
থিটা এক্স টা জি কোসেন জি এক্স কি করে হলো ওটা বুঝলাম না।
you were
অর্ডার অফ
not in
থিটা
the
এক্স টা
last
অর্ডার
class.
অফ জি কোসেন জি এক্স ওটা কি করে হলো বুঝলাম না।
There is a bijection from G mod Gx to the orbit of x. This was done in the last class. Have you forgot the result?
আচ্ছা জি
Okay, so
কোসেন জি এক্স জি থিটা এক্স।
yeah, so what was that? We were sending G mod Gx to Gx. Okay, you can check that this is a bijection.
ও আচ্ছা
Okay, just check it. This is done in the notes. Those 3 notes that I have sent you, it is done there. Or else you ask me, I will do this. Tau G is called an inner automorphism. So set of all inner automorphisms are called in G. Okay, so they are saying that this in G is the set of all inner automorphisms, so that this is a normal subgroup of odd G. Okay, so how do we do it? Okay, let's see. So let's take tau G belongs to in G, and let sigma belongs to odd G. Okay, so what is tau G of sigma, or maybe I should write tau G. Oh, by the way, tau G inverse is tau G whole inverse, huh? So what is this? This is nothing but tau G inverse compose sigma compose tau G. So let's act this on an arbitrary element of X. Okay, let's see what happens. So what do you get? Tau G inverse sigma of, what is tau G of H? G inverse, right? What is that? Tau G inverse of, what is that? See, since sigma is an automorphism, we can write this, right? What is tau G inverse, by the way? If I am not mistaken, tau G inverse is G inverse sigma G sigma H inverse G, right? This is tau G inverse of this, na? That is, sorry, this was G inverse, na? Right? Thus we get G inverse sigma G sigma H, this is sigma G whole inverse of G. What is it? This is nothing but sigma G inverse of G whole inverse sigma H sigma, no, maybe I should write like this. This is G inverse sigma G sigma H G inverse sigma G whole inverse third inverse. So this is tau of, wait a minute, but I will have to sigma, na? I will have to take sigma outside. Wait a minute. Since sigma is an automorphism, there exists G naught belongs to G such that sigma G naught is G. Thus we get tau G inverse sigma G H. This is sigma G naught inverse sigma G sigma H sigma G inverse sigma G naught, right? Thus we get sigma G naught inverse G sigma H sigma G naught inverse G whole inverse, right? So what I will have to show? I will have to show that this is of equals to some H. I will have to come back to. Okay. This is almost done. I am just struggling to find it. I'm missing. Am I missing something? Am I missing something? Computation. Oh, none of you corrected me when I did this. You are not looking carefully enough. I should be computing this, isn't it?
সিগমা তাহলে শিখবেন, হ্যাঁ আমি একবার খেয়াল করেছিলাম, বলা হয়।
That's so. What is it? Sigma inverse of. We lost so much time. G sigma h G inverse. This is nothing but sigma inverse G. Sigma inverse of sigma h, which is h, and sigma inverse G inverse. Right? Yeah. So this is sigma inverse G h sigma inverse G whole inverse. Thus we get this is tau sigma inverse G of h. Okay. So sigma inverse tau G sigma is tau sigma inverse G. This is also an inner automorphism, na? So we are done. So in G is normal. Okay. How many are there? Explicit exhibit an automorphism of Z6 which is not an inner automorphism. Okay, let's see. Tell me an automorphism which is not an inner automorphism. Z mod 6Z. This is class of 0, class of 1, class of 2, class of 3, class of 4, class of 5. So Z mod 6Z to Z mod 6Z. How many automorphisms are there? How many? There are only 2 automorphisms, na?
So the Z star 6Z, Z6 star zeta.
One is identity and sigma, where sigma of x is 6 minus x. Basically, you will have to send 1 to 1 or 1 to 5. That's it. Only 2 generators are there. Like the one Abhishek was talking about. It has only 2 generators, na? The multiplicative group. So there are only 2 automorphisms. This is not an inner automorphism. Understood? This thing is not an inner automorphism. This sigma. Because if if sigma is of the form tau g, then sigma of x is, or maybe say, what is tau g of x? Tau g of x, what should that be? That is g plus x minus g. Since it is abelian, it is x, implies tau g is always identity. Okay, so in g is tau g here, identity. Okay, the next problem we have is if G mod Zg is cyclic, then G is abelian. These are well known results. If G mod Zg is cyclic, then G is abelian. So, how to do it? So, G mod, I am writing it Zg, huh? Zg is center of G, denoted by Cg also. So, it is cyclic. So, suppose this is generated by AZG. Okay. Okay. So, let PQ belongs to G mod Zg. Then P is of the form a to the power I Zg, Q is of the form a to the power j Zg. Okay. So now PQ are cosets now. So this is then G is abelian, will have to show. Okay. No, this I made a mistake. Wait a minute. So let's take PQ belongs to G. Okay. Then what I am trying to say is this. I am trying to say is PZG is since that is cyclic and QZG is a to the power j Zg, right? So what does it mean? This means a to the power minus ip belongs to Zg and a to the power minus jq belongs to Zg, right? So there exists Z1, Z2 belongs to Zg such that and a to the power minus jq belongs to Z2. Okay. So P belongs to a to the power I Z1 and Q belongs to a to the power j Z2. So PQ is a to the power I Z1, a to the power j Z2. Now since Z1, Z2 belongs to Zg, they commute. So you can easily take this and do this. Since Z1 and Z2 are belongs to Zg, that is QP. Okay. So G is abelian. Show that the center of S4 is E. Conclude that S4 is isomorphic to a subgroup of inner automorphisms of S4. This is a good problem. This is a good problem. If I am going too fast or too slow, please let me know. So first define, show that the center of S4 is E, right? Conclude that S4 is isomorphic to the group of all inner automorphisms of S4. Let's see. So first define this mapping the obvious way. G comma H goes to G inverse. Okay. So it induces a map theta from S4 to odd S4, right? By G sending to tau G, and we all know tau G from S4 to S4 is basically H going to G inverse. And image of theta, we know it is isomorphic to S4 mod cot theta by first isomorphism theorem. Okay, this is general. What is cot theta, by the way? What is cot theta?
Cot theta is the center.
Yes. So if you act G on G by conjugation, then the theta you get from G to odd G, you can check that cot theta is basically ZG. I think this was done in the last class. Cot theta is ZG. So this is S4 mod ZS4, right? What is im theta, by the way? Okay, im theta is contained. Maybe I should be writing like this. Also, im theta is a subgroup of in S4, na? Because these are inner automorphisms, na? So image of theta is of course contained inside in S4. Now tell me, what is ZS4? What is center of S4? What is ZS4? Please, what is center of S4?
S4 যেহেতু highly non-commutative group তো E হবে center.
What is highly non-commutative?
মানে কেউ কারোর সাথে commute করে না.
Yeah, but you will have to still show it, na? We will prove it, okay? Let's take, okay, maybe, suppose Ij, this 2 cycle belongs to ZS4, okay? Okay. Ij KL belongs to this 1, 2, 3, 4. This is a standard trick. Take a 2 cycle so that your computation gets easy. Okay, so what is Ij? I am seeing whether Ij commutes with JK or not. Okay, so what is this? Let's see. So what is ij jk of I? What is that? Anyone please? That is j. Is it clear now? jk is acting on I is fixed. Now I is going here and to j, right? You are familiar with this, na? Then you are acting on j is sent to k, okay, because k is fixed. You are familiar with this, na? K is
হ্যাঁ
sent
দাদা।
to j is sent to I. L is fixed, of course.
তুমি কি পাতি কম্পোজিশন করছো নাকি?
Yeah, of course. What else?
আচ্ছা,
And what is jkij of I? What is that? I to j, I to j, j to k. See, they don't match. Okay. They are sending j to I. They don't match. K to j probably and L to L. Okay. So ij jk is not jkij. Okay. So no two cycle. It is a so ij is not in ZS4, right? So no two cycle is in ZS4. Okay. So that's done, na? That's done, na? That ZS4 is identity. Because you can write any cycle as a product of two cycles, right? As one can write any permutation as a product of two cycles. There is an alternative method as well, okay? We will do that and conclude the class. So alternative method is that we will use Sylow's theorem to do it actually. No, not actually Sylow's theorem. Let's compute the conjugacy classes. Okay. Okay. So please tell me how many conjugacy classes are there. This many, right? What? This many, na? Are you aware of the fact that two permutations? Are you aware of this fact? Two permutations in Sn are conjugates implies and implied by they have the same cycle structure. Are you
হ্যাঁ দাদা।
okay? So enough to compute the number of two cycles, then three cycles, and so on. So please tell me how many two cycles are there. This is right. How many three cycles? Let me first know. Do you even know how to compute it? Or else I will teach you.
হ্যাঁ দাদা, এটা জানি।
Right. How many are there? 4C2, this 3C2.
তো সাইক্লিক পারমুটেশন ইউজ করে করছো
Yes,
তো
yes. How many product of two cycles are there?
4টে।
Why? First you take 4C2, only 2 are left, so that is 6, na? Have I made a mistake? Oh, only 3 4 cycles are there, na? 1 2 3 4, 1 4 2 3 and 1 3 2 4. Right? Only this many. Right? So how many total in total? 23, right? So ZS for cardinality, how much is that? You understood what I have done? I have used the class equation.
হ্যাঁ দাদা।
Okay. So ZS4 is only one, okay? Pritam, okay? Okay. So that's it for today. We will finish this exercise. We finish this exercise in the next class, and we will move to Seiler's theorem. I mean the exercise beyond Seiler's theorem, which is probably page number 96, I think. Yeah, page number 90. We will do that in the next class. Okay, that's it.